Welcome, stargazers. Imagine a celestial event so immense that it casts shadows on Earth, visible even in daylight. We might be on the brink of witnessing such a spectacle with the star Betelgeuse in the Orion constellation. Betelgeuse is behaving unusually, hinting at a possible supernova that could illuminate our sky like never before. But when will Betelgeuse explode, and what will it look like? Researchers are eager to explore these questions. Located about 650 light-years from Earth, Betelgeuse is no ordinary star. As a red supergiant, it's one of the brightest stars known, shining with a brilliance over 100,000 times that of our Sun. Its significance lies not only in its brightness but also in its historical and cultural importance. Named after the Arabic phrase Yad al-Allah, meaning the hand of Orion, Betelgeuse has been observed by ancient civilizations for centuries, guiding travelers and captivating astronomers with its distinctive red hue. Imagine a single star outshining our entire solar system. To put it in perspective, if Betelgeuse replaced our Sun, its outer edges would extend all the way to Jupiter. At around 10 million years old, Betelgeuse is much younger than our Sun, which is about 4.6 billion years old. Its massive size means it consumes its fuel much more rapidly, leading to a shorter life expectancy compared to other stars. As Betelgeuse nears the end of its life cycle, it won't simply fade away. It will end with a spectacular supernova explosion, an event of unimaginable energy and brightness that could potentially outshine an entire galaxy. The last time Earth witnessed a nearby supernova was in 1964, with the Kepler supernova, which was visible to the naked eye for over 18 months and even shone during the day. Historical records from various civilizations document this event, and remnants of the explosion can still be observed today with modern telescopes. Such cosmic remnants provide invaluable insights into the violent deaths of massive stars. Now, consider a supernova so bright that it rivals the full moon, casting shadows across Earth at night. The radiation from such an explosion could affect our atmosphere and satellite operations. Betelgeuse's recent fluctuations in brightness suggest we may be approaching such an extraordinary display. Between October 2019 and early 2023, Betelgeuse underwent a remarkable phenomenon known as the Great Dimming. Its brightness, which had been stable for decades, suddenly decreased significantly, catching the attention of both astronomers and casual stargazers. By April 2023, observations revealed that Betelgeuse had returned to its usual brightness, sparking discussions about the nature of these fluctuations. This remarkable change raised questions about what caused the dimming and subsequent brightening of one of the most prominent stars in our night sky. Stars are dynamic entities, experiencing life cycles filled with mysteries. Betelgeuse had maintained a predictable 400-day brightness cycle, so the recent dramatic changes challenged our understanding of stellar behavior. While researchers are still investigating, a compelling hypothesis has emerged, suggesting that Betelgeuse may have been expelling vast amounts of material into space, similar to a cosmic volcano. Observations from the Hubble Space Telescope revealed that Betelgeuse had lost a staggering amount of its surface material, around 400 billion times the mass typically ejected during similar solar events, equating to several times the mass of our Moon. This ejection may have created a thick dust cloud around the star, affecting its apparent brightness and making it harder to observe. As this dust dispersed or was blown away by the star's radiation pressure, Betelgeuse's brightness increased once again, revealing that the star is still very much alive. These recent events suggest that Betelgeuse may be nearing the end of its life cycle. A supernova occurs when there is a sudden change in a star's core, which can happen if it accumulates too much mass from a companion star or, in Betelgeuse's case, exhausts its nuclear fuel, leading to a catastrophic collapse. Massive stars like Betelgeuse begin their lives in molecular clouds, fusing hydrogen in their cores during a phase known as the main sequence. This stage lasts for millions of years and forms the foundation of a star's life. As we continue to observe Betelgeuse, we may soon witness one of the universe's most dramatic events, unraveling secrets of stellar evolution and the cosmos. As hydrogen runs low in stars, they turn to new energy sources, consuming helium and then moving to the fusion of carbon and oxygen. This progression shifts from the hydrogen burning phase to the helium burning stage, which is marked by a star expanding into a red giant. Over time, as helium reserves dwindle, the star undergoes further expansion and transitions into burning heavier elements. The larger the star, the quicker these changes occur due to immense gravitational forces. Eventually, iron begins to form at the core. Unlike lighter elements, iron does not release energy when fused, which means that the energy produced becomes insufficient to counteract the star's own gravitational collapse. The star inflates, then undergoes a catastrophic collapse, resulting in a powerful supernova explosion. Betelgeuse, also known as Betelgeuse, is potentially nearing this explosive end, with recent studies from Japan's Tohoku University suggesting it may be in its carbon-burning phase. Lead scientist Haduki estimates that the core could collapse many years after its carbon is depleted. However, some researchers, like those from Hungary's Konkoly Observatory, argue that Betelgeuse is still in the earlier helium-burning stage. Regardless, there's consensus that Betelgeuse is set to become the Milky Way's next supernova, although predictions on when this will happen range from a few years to 100,000 years. As we ponder Betelgeuse's fate, we must remember the nature of our observations. When we gaze at the star, we're seeing light that left it 650 years ago, meaning that any changes, including a potential explosion, would take centuries to reach us. This makes each observation like peering through a cosmic time capsule. The implications of such events extend beyond astronomy, prompting reflections on our existence in a vast universe. The recent supernova SN 2023X, observed in a neighboring galaxy, has reignited discussions in the astronomical community. Its brightness and characteristics remind many of what is expected when Betelgeuse meets its end. The connection between these two events emphasizes the interconnectedness of cosmic phenomena. Should Betelgeuse explode, it would alter the night sky, leading to profound contemplations about transience, time, and our place in the universe. Supernovae play a crucial role in cosmic recycling, dispersing heavy elements that contribute to the formation of new stars and planets, essential for the evolution of life. Studying these explosions also aids our understanding of cosmic distances, informing us about the expansion of the universe and dark energy. Moreover, the anticipated explosion of Betelgeuse serves as a poignant reminder of life's fleeting nature. Throughout history, humanity has looked to the stars for inspiration, and the possibility that a visible star may be on the brink of monumental change prompts us to reflect on our own lives. This cosmic spectacle encapsulates themes of destruction and rebirth, urging us to consider our personal transformations. As we await further insights regarding Betelgeuse, we find ourselves at a fascinating intersection of science, culture, and philosophy, inspiring us to explore the mysteries of the universe.